Hi everyone, I am an engineer for fun, and today I want to share with you some information about the STM32F4 boards, also known as black pills. I want to address some upload inconsistencies that can happen sometimes, and I also want to show you an option to use a bootloader so you don't need to press any buttons anymore and it's all automated, the upload. So these boards were initially manufactured by React Studio, but nowadays they are quite popular because they are quite fast, they have a lot of peripherals, and they are quite cheap. They also have good support online, so you can use them along Arduino IDE or Platform IO. So if you have one of these boards or if you want to get one of these boards, I heavily recommend the tutorial from Caleb Martin. I will leave the link in the description. This tutorial is very good because it goes through how to install the tools, how to upload the code, how to use the board, and then later maybe how to use the programmer or Platform IO, things like that, which are really cool. This video also has a link to the Discord page of Caleb, created by Caleb, or not page, but the server, where people talk about ST microcontrollers, which is really cool. You can also join. I recommend you to do so if you want to develop with those boards. There is always people to answer the questions and so on. And then one of the questions that I see popping up there and also popping up sometimes in other places in the internet is that the upload is not working even in the DFU bootloader. So for you that don't know, the DFU is called Device Firmware Update. It's a mode that is present in the hardware where the board accepts programming via the USB, as long as you use the correct software, which is the STM32Cube programmer. Caleb also mentions how to install that in the video. So these inconsistencies, they are not covered, or at least I didn't see it covered very much on the internet, and that is due to this, let's say, the capabilities of the board. Like the board is not only capable of receiving code via the USB, but also receiving code via the serial port. The serial port here is like this TX1 and RX1, so pins A9 and A10. So if there is any disturbance in the A10 pin, more specifically, which is the receiver, sometimes the board can get confused where to listen to, and then it stops listening to the USB and listens to the, let's say, serial pins, but no communication comes. And as such, the DFU bootloader mode doesn't work. So if you want to have a consistent bootloader, DFU bootloader, sorry, you need to ground the A10 pin. Simply connect it to ground. Now your problems are gone. Some boards don't need the grounding. It's funny. So like maybe people can get away without it, but if you want to have a consistent behavior, it's better to ground it. So this is the first point that I wanted to cover. The second point is that if you're tired of pressing buttons, because this DFU bootloader mode, you need to press the reset, then the boot, and then release the reset. This is practical if you're uploading a few times the code, but if your board is in an enclosure or if the board is far away, it can get tiring. Also, maybe you don't have a programmer. So there is an option, which I never saw covered on the internet, which is using a bootloader, a separate one. So instead of using the hardware from a factory, let's say features, you can install a small code that will run before your application that will basically look for any USB incoming messages and then program the board accordingly. This bootloader is called an HID bootloader. It's similar to something that was present in other boards, or not present but available for other boards from ST, like this blue pill, which is the STM32F4. So this is let's say an evolution for this board. You can find in this repo here, that I'll leave the link in the description, the pre-compiled bootloader under the releases. This bootloader is basically a small application that is around 16 kilobytes that will reside in your ROM, and it will be executed once the board is powered on. It will check if there is any attempt to code it, to program it. If there is no attempt, then it goes forward and runs the normal code, which is quite interesting. For those boards, since they are quite, let's say, full of resources, 16 kilobytes is not much. they have upwards of 300 kilobytes. Actually, they have more, up to 500 kilobytes of ROM, so 16 is almost nothing. So if you want to install this, first step is coming to the releases and selecting the bootloader for your board. And then you can select if you want the binaries or the hex. For people who are not so used to it, the binaries and the hex, they have the same content. The difference is the binaries, they only have the code, so you need to manually set where the code needs to be written. And the hex, you have both the code and the addresses, so you don't need to set anything manually. Otherwise, they are the same. Alright, I have STM32F4 here. So I will connect it to the computer. For now, you will see that there is no sound and no reaction because the board is empty. So here, if you look into the USB, there is nothing connected. But I will now perform this button pressing to reach the bootloader, the DFU bootloader. This is the only, let's say, the only time that you need to get to the DFU. Afterwards, you just need to press the button once, and then you will never need to press buttons again if you don't want to. So let's press reset, then boot one, lift reset. Then you can see that immediately the STM32 bootloader mode, which is the DFU, shows up. If we come now to the STM32Cube programmer, which is mentioned how to install it on Caleb's tutorial, you can refresh here and then you'll see that there is a USB connection available. So now we can connect, and then you see at least my board is empty. Maybe your board comes with the React bootloader, but once you get to the DFU mode, it will be the same. Now we can open the file. I previously downloaded the bootloader, which is this file here. So now here's the file. I will now code it or download it to the board. Alright, download complete. Now we need to reset the board. So to get to the HID bootloader, only on the first time you need to press the user button, which is this button close to the back of the board here, this button here. So you press it and then you reset the board. Okay, here it will complain that now the connection is lost because we got out of the DFU mode. But now if we come here, you see that now we have a different bootloader. We have the bootloader that was made by these people. Here you can see HID bootloader. So now your board is set and ready to receive code via the HID mode. So we'll come here to Slugger, which is basically an Arduino plugin for Eclipse, but you can use any. You can use a normal Arduino, you can use Platform.io, and then I will quickly verify the code or compile it. Shouldn't take long. And now we can upload Sketch. But before uploading, let me show you the settings that I used. So the important thing for this bootloader to work is that you always enable the serial, and you also here have the USB support with the CDC. This is basically because the reset is sent via the serial port. So just right when the board turns on, it shows up as an HID bootloader. After it finds that there is no tries to program it, it will go to the code and then it will show up as a serial port. Here, in this specific case, when we first install the bootloader, since there is no other code, it will get stuck in the HID mode. This is why it still shows up here. So you need to have this enabled. And then here, the upload method, you select HID bootloader. And now we can upload the code. So it should find the board right away. And then you can see that it will send a reset, and then it will search for the COM port. Now, if you look in the USB, the board shows up as a USB COM port now, no longer as an HID. So it's only right after it's reset. Okay, so now with this, you don't need to press any buttons. If I want to upload the code again, I simply press upload. The reset will be sent via serial, as you see this toggling DTR. and then the programming will happen automatically without any button pressing. So I hope with this have show something useful for you, that you can now more use, let's say, this board on more practical applications without so much button pressing. And then I hope to have maybe teach something useful. Thank you for watching, and I see you again next time. Thank you very much. Bye.